Okay, what I am noticing on number 6, what I'd like you to pick up on, if you look at the left-hand side compared to the right-hand side, the left-hand side has got 2 different trig functions going on, but on the right-hand side, we only have 1. That's telling me somehow we've got to like get rid of or eliminate or something, rewrite something so that we just have the 1 trig function. So in other words, we're going to do a substitution. Right, so we're going to substitute. So if you notice, we want things in terms of cosines squared. So let's think about how we can rewrite sine squared x or a or whatever letter you want to use. So think alternative form for your identities. We know that sine squared x is equal to 1 minus cosine squared x. Right? So let's rewrite. So we're going to keep the cosine squared a as it is, but I want to rewrite that sine squared as 1 minus cosine squared x. I'm not being consistent with my letters. I'm sorry. Let me fix that. Let me use a. We are distributing that negative. So if we have minus a negative, then that becomes plus a cosine squared a. And so then, if you notice, we can combine together those 2. So we get 2 cosine squared a minus 1, and that's what we wanted. Okay. So there was a little bit of a trick on that one. It's not always the case, but all right, ideas or suggestions on how to start with number 7? I'm seeing a couple different ways to think through this one. Distribute the cosine squared x? Okay, we can do that. Let's do that. So let's multiply and distribute, and we get cosine squared x plus, bless you, tan squared x times cosine squared x. And so I'm thinking I want to rewrite this, whoops, all right, Ireland. I'm thinking I want to rewrite this tan squared x then. So I'm going to keep this as cosine squared x plus sine squared x over cosine squared x times cosine squared x. And I'm seeing that those cosine squareds divide out, and so I'm just left with cosine squared x plus sine squared x. Whose identity is that? That's Lily's, isn't it? 1 equals 1. All right, questions, comments, thoughts on 6 or 7? Okay. Yikes. That's not good. Was that Mr. Weber over there? Is that what he just said? Was why he was hollering? Yeah, sorry. No worries. Okay. All right, there we go. Okay, number 8, we're gonna do similar processes we did for number 5. So I like that we are waiting a little bit later to do that because you guys have to remember what that trick is. So what are we gonna do on number 8? Multiply by the conjugate. Are we gonna multiply by on the left or the right? The right-hand side. So we are multiplying top and bottom by 1 plus sine x over 1 plus sine x. So we get cosine x times 1 plus sine x all over. Our denominator becomes this 1 minus sine squared x. Guys, what's that equal to? Yeah, that is cosine squared x. So we've got our cosine squared x here. And what happens with this? Divides out with one of those, and we are left with 1 plus sine x over cosine x, and that's what we wanted. So we are good to go. Nice. Okay. Comments, questions? I'm kind of zipping through some of these.
So why do you do not the left side?
We typically want to focus on this, if the term that in the denominator has the 1 plus the trig function or 1 minus the trig function. So we typically, it's not that it won't work. You could use that side. That would definitely work. But we tend to want to focus on denominators rather than numerators. All right, thoughts or ideas for number 9? What do you think, guys? Change the cotangent? Okay. Okay, so we want to keep this as sine x over 1 plus cosine x over sine x. And then this is all over cosine x over 1, basically. Okay? All right, now what? I'm thinking we need to do a keep it, change it, flip it. So we're going to multiply by 1 over cosine x when we flip. And we're going to multiply times that. Okay, so now we need to distribute, right? So when we distribute here, we're going to combine that together to make it a nice, pretty fraction. For that second term, when we're multiplying, we've got 1 over cosine x times cosine x over sine x. And that's going to simplify. So, okay, that's sine x over cosine x. What is this equal to? Yep, that gives us tangent x. And then we have plus 1 over sine x. Think about what we're trying to get to. Right? And that is cosecant, isn't it? It works. Beautiful. Nice. Okay, onward. Okay, let's take a look at, okay, I do want to talk, we're not going to go through this one. This might be a good one for you to practice on your own, but I just want to make sure we have enough time to do some of the other problems we need to do. So common denominator here though, right? So you're going to multiply by 1 plus cosine x, top and bottom. So I want to make a note about what you would do on that one, but we're not going to finish solving that. You guys can do that at some point. But I do want to look at this one because this one is a little bit different. That tangent squared plus 1, whose identity is that? That's you? Okay, so 1 plus tangent squared we know is secant squared x, right? And 1 minus sine squared x, that's cosine squared x. Please notice something here, guys. The tendency, and what I've told you that we want to do most of the time, is we want to rewrite stuff so that it's in terms of sines and cosines. But I need you to notice in this example, in this problem, we're trying to get to secants. So I'm going to want to keep this secant up on top as secant. So instead, we're going to keep that secant squared. Instead, I want to rewrite that cosine squared. So we're kind of doing the reverse of what we would normally think of. So on this one, because we're trying to get to some more secants, I want to rewrite that cosine squared x as 1 over secant squared x. And then if you think about it, if we do keep it, change it, flip it, we are going to get that secant to the 4th x, because we're multiplying secant squared times secant squared, and we get our secant to the 4th. So here's an example where it's helpful to have where we're trying to go, what we're trying to get to kind of help lead us in the thought process of what we're going to want to do. Okay, do you kind of follow that, I hope? Okay. All right. There are many instances where factoring comes in handy and is helpful. So I just want to review kind of some of the basics of factoring. We'll look at just like one example down here, and then I'll explain what I want you. There's one problem. I don't know if you remember when we did the simplifying packet that I gave you. Remember there was that one problem, number 14, that I said, hold off on that. We're going to talk about that one later. So we're going to talk about that one because it involves factoring. So, all right, let's take a look here. If we're going to factor, for this first one to factor, we've just got to factor out a GCF. So, Alex, what's the common factor in those two terms? A. So we need to pull out an A or factor that out. And so then what we would be left with is 1 minus b squared. And actually that can factor again because that's a difference of 2 squares. So then we would say that's 1 plus b times 1 minus b. That poor desk. It's bad. Similarly, I have a couple more problems here where they are differences of 2 squares. So x squared minus 1 we know is going to factor into x plus 1 and x minus 1, right? And this 1 minus x squared is going to factor into 1 plus x times 1 minus x. But let's take a look at this top right. And then we'll look at the example from the packet. Two different ways that you can write this. So notice we need our x. To get our x squared, we need 1 here. And to get the signs correct, they both need to be negative. So you can write it that way, but the tendency is to want to be able to see it typically in that format where we're doing quantity squared, because probably more than likely that's going to divide out with another term similar to that. Okay, so kind of keep that in mind, back in the memory banks as a possibility. Okay? All right, let's look at, this is the problem. If you know where that packet is and want to write it in there, if you want to write it here or just watch. The thing that I am noticing about this particular problem is that I'm seeing squared, so I'm thinking Pythagorean identity on the top. But in the denominator, I'm seeing a secant theta plus 1. And so that leads me to kind of think of the fact that I can rewrite this tangent squared theta as secant squared theta minus 1. I'm going to keep that denominator the same. I'm going to keep that as secant theta plus 1, and then I still have that plus 1 here. But how can I factor that secant squared theta minus 1? That's a difference of 2 squares. There you go. So secant theta plus 1, secant theta minus 1. So that's how the numerator factors. And then that means we can eliminate or divide out, right? Those are common terms there that we can divide out. So then we are left with secant theta minus 1 plus 1. So that just simplifies to secant theta. So a neat little trick with that one, just to remember to realize that you have to factor. Okay. I'm trying to decide which one down here I want to do. All right. 6 is very much like the one we just did, this example I just did over here. So let's do 3 or 5. Which one should we do? Catherine, 3 or 5? 5. Okay, let's take a look at 5. We need to find, I'm seeing common factor in both of those terms. So what's our common factor there? Cosecant squared x, there you go. So we need to factor out that cosecant squared x, and then we are left with 1 minus cosine squared x. And we know 1 minus cosine squared x is equivalent to sine squared x. And what's the relationship between cosecant and sine? Yes, they are reciprocals, and we know reciprocals, when we multiply them, are equal to 1. So 1 is equal to 1. We are done. Right? Nice. Okay. Those other examples involve factoring too, if you want to try those at some point, but I want to make sure, I want you guys to have a decent amount of time to kind of get started on some of what you're going to be doing. One other example I want to show you, and kind of one little concept to talk about. We have focused our attention strictly on one side, and I will, like some math purists would say, you should always strictly only work on one side. Others would say, it's okay if you're gonna do, if you notice what it says here, you should only do minimal work on one side, and then try to get the other side to look like that first side that you worked on. So if you have to do a little bit of work on one side, it's okay. But then you better go back and work on the other side and get it to look like what you've just changed. Okay? The other thing, the problem I really want to focus your attention on this page is number 3, because it looks really messy. But what I want you to notice straight away, right away, immediately, is that we have a sine x times cosine x in the numerator, and we have a sine x times cosine x in the denominator. So guys, that just totally divides out immediately, and so our left-hand side cleans up to something not too bad, right? So that's where we would want to focus our attention then is on this side over here on this right-hand side, and do the distributing and kind of clean up from there. Okay? Mm-hmm.
So for number 1, which side would you start on? Because they look like.
Yeah, that's 6 one, half dozen the other. Actually, I would do a little bit on that one. I would definitely do a little bit of, let's do that one really quick, because that should be a really quick one. What's secant times cosine? 1. So this is 1, so we have 1 minus 1, so we get 0. And what's tangent times cotangent? 1 minus 1, so we get 0 equals 0. So yeah, that's a very small amount of work on either side, but then we kind of get that. Okay. All right. So for classwork and then for homework, I would like for you to try the other problems, those factoring problems down at the bottom of page, what was that? 8. I would like for you to finish up with this problem here on page 9. And then you are going to move over to pages 11 and 12. That's actually where the main work is that I want you to do. And I want to look, there's 2 hints that I want to give you. And they are on 11, on page 12. Okay? So it's a little bit longer assignment, but you've also got time to get started here in class. And I want you working in class, getting help from each other, that type of thing. Okay, so on page 12, though, take a quick peek. So this is the last 2 problems. You are going to factor out a GCF. Oops, here we go. GCF here on the left-hand side. So that's a hint for you on that one. And then on this one, the hint is to rewrite that tangent squared using an alternative form. So think of your Pythagorean identities and write an alternative form, keeping in mind about this 1 plus secant. Okay? You could do this problem using that trick, but it's easier to do this alternative form and then simplify.
So are we submitting 11 and 12?
So you're going to submit